It's-
And
I,
then, of
s-
course, we'll have the
I
delay kick
swear
in.
this thing always throws me for a loop. Like, it does one thing and then it says another thing, but we're here. But we're here.
And we're here.
Hi, everybody. Welcome in. I know some people are already waiting in the chat, so thanks for your patience. I know I started the chat on this about a half hour prior, in case anybody wanted to sit there and talk amongst yourselves.
I like that idea personally. Get a
Yeah,
waiting room going.
in case there's any questions or whatever. So anyway, we're here. We're gonna talk about current events and if you saw on Facebook the wonderful acronym HILDCAA,
HILDCAA.
HILDCAA, which I was
Sounds
told
Swedish.
that from Ray there that this isn't a real thing, but I promise you it is. It's in research papers, so
It is also
yeah,
true that it's the most ridiculous acronym you've probably ever heard.
it is. I had to put it in there what it is because I can't tell you offhand because I have to like read it. Um, but it's a magnetospheric state. So the one thing that we've found with doing these kinds of broadcasts and education type things is we don't really talk too much about magnetospheric states. It's just, is the aurora out? Yes or no? And here's some solar wind data. But nobody really talks too much about, until we started doing it, the steady magnetospheric convection, sawtooth events. This is another one, HILDCA. And there's others too. And as we learn more and more about it, because we actually are going to be working, I'll just mention it, even though I probably shouldn't mention it, but because it'll probably pique people's interest. But we had something very, very interesting happen Friday that was extremely localized, and we're going to do a research kind of project based on that once we get more scientific data. So there's just a lot that we don't totally understand, what goes on with the magnetosphere. So that's what makes it both interesting and frustrating at the same time because we're used to having answers at our fingertips that we have like black and white answers for. Like, hey, this causes this, and we don't really have that too much here. We get weird states, we get weird things causing stuff to happen. So we just mosey along. But anyway, we're gonna start with current events because we do have some stuff going on. We had that coronal hole. We have more coronal holes on the way. So yeah, we don't really have any sunspot group. There was that really cool sunspot group that looked kind of promising, but like usual, it gets to the Earth facing part and it just decides it doesn't want to do anything anymore. So I'll hand it over to Christian here. He'll take you through it.
That was a pretty good summary at this point as to where we're at. I figured we'd look at least current solar wind data, which we're clearly in the midst of the coronal hole, the first negative polarity that came in. It's been straight up negative for like a day now, I want to say. Density, at least according to ACE, is below 1. And solar wind speed is slightly decreasing a little bit, but we're still averaging about 560 to 570 kilometers a second. So good high latitude aurora.
Yeah.
And then as far as the actual looks, so going back just a little bit, I am using the PFSS model on here as well, so we can determine polarity. So we know this is the positive section, red, blue is negative in this case. But we had that positive coronal hole come through. This was way, way later, earlier, so a week and a half ago. So moving more to the relevant piece. This is the section we're looking at. So the first negative coronal hole that came in. Whoa. I wonder what was going on there. Calibration. That's kind of cool.
Yeah, that's what it looks like.
But point is, and now we're in an entirely negative sector. We also have a northern negative hole, a central negative hole, and a southern negative hole. Hey, look at that. So it's going to be kind of interesting to see how this all works out because we'll probably only have a small decrease in speed back to normal levels before we start seeing some higher level jumps again. But really, kernel holes. And to be quite honest, this is probably going to be a consistent thing with how we do our forecasts because kernel holes are now the prominent features on the sun. And I stress that because this is our current look of sunspots on the sun. We don't need the PFSS anymore. Even in the last couple of days, I only did this for a day, so there's not much there, but there really isn't much there. In fact, if we want to go zooming in, the southern hemisphere still has the most interesting looking ones, at least. But looking at the polarities, we have a fairly simple beta region that's growing pretty fast, but And then we have this old region that we thought was interesting that is separating. And then we've got now a new negative polarity spot coming up that I assume this one will merge with. But this is kind of its own independent island of negative umbra, which is quite the interesting setup. We also still have some high latitude features over here, it's pretty uncommon to see down at that latitude. I wonder how far down that is. Yeah, about minus 25. Usually seen within plus or minus 10 degrees of the equator at this time. It's fun to see the high latitude ones come through. That's pretty much it for sunspots, though. Really nothing impressive. And then again, coronal holes, expect several of them passing over the next week, roughly, starting probably in the next couple of days.
That's correct, because from what I've seen so far with the forecasts that are out there, they have some geomagnetic, well, Met Office usually does this, but in the forecast for Friday in particular, because of the bigger one of those coronal holes, my guess.
The central one, I'm assuming, a little more nicely
Yeah,
placed.
and then they're watching some stuff on the backside to come through. There was a pretty decent eruption on the backside, so assuming that there's some fun stuff coming around the corner, but if history repeats itself like it has been, it'll fire
It
something
won't
really
be.
cool right off the limb and then quiet down to nothing.
Would you like me to share the presentation?
Oh, I can.
Or
I
did
guess
you-
I could share
Okay,
it. I'll bring it up.
as long as you've got it.
So up next, we're going to talk about what we saw with this coronal hole. And it's interesting. It's something we were thinking we were going to start seeing with the declining phase when these coronal hole features start coming more prominent, like they are. And we'll just get into it. So this was primarily coronal hole 27. It had negative polarity, as you it. So this was a great lesson here, because there was the argument about positive polarity versus negative polarity and the Russell-McFerrin effect, and some people are saying it doesn't have effect, but I don't know. This seemed to have a much bigger output than the last one did, even though the last one was like the size of the entire sun. So I'll just leave that at that. You guys can argue amongst yourselves if the RM effect is a thing or not. So anyway, a small, let's see. So yeah, so the event primarily we're talking about is coronal hole 27, preceding events. There actually was a glancing blow from a CME. It wasn't very big, but there was one, and we'll show it in the data. And the sector boundary crossing, that's the other thing that kind of came up, because sector boundary crossings can drive some aurora activity too. So that was the other thing with the past event. So here is the solar wind data and kind of what we have highlighted here. The box in green shows what looks like the transient CME feature. Then it got kind of messy because there's other things mixing in here too. So we just kind of skipped over that. And the sector boundary crossing is this right here, where we went from the positive to the negative part of the sun. And then it goes into the coronal hole. So that's pretty kind of cut and dry, I guess. You can kind of see where things are flux warping and things just get kind of jumbly there. But so what we saw here, coronal hole, and like Christian was saying, we're getting out of the effects of it now a little bit. I think this one actually, this one, let me just look in here, because it got pretty high in the speed. It was over 700. So it was another pretty fast one at its peak, which is cool to see. It's nice to see these fast streams again.
Yeah, if these peaks are legitimate that I'm
Yeah, like
seeing,
here, and here.
760. Yeah, these look legitimate to me.
Yeah.
778 is the highest I see for the data point, at least.
Yeah, like I'd say it's probably average over 700, at least through this sector here. So that's pretty good. So what is a HILDCAA event? So this is a high intensity, long duration, continuous aurora electrojet activity. This is why I was never going to commit this to memory. But
Also, they could have been nice and put a vowel in between the D and the C so we could say it.
yeah,
But
high intensity, long duration. So science people are funny. Usually they come up with acronyms that are very descriptive. I mean, if you look at the aurora electrojet above, that is a long duration continuous aurora electrojet. It just kept going and going and going and going and going and
Energizer
going
Bunny.
and going and going. So that is what a HILDCAA event is, and we will be seeing more of these. So, but hey, let's talk about some differences. So they actually do have criteria for this too. Has to at least go on for 2 days, and you have at least one AE value drop above. I gotta move these, like moving our faces around. I like it because you can see it in OBS, and I'm like, wait, okay, let me put it down here
But
so I
then
can
it's
read.
covering up the slides.
So I can read what
I
I'm
noticed
doing
that.
here. And yeah, AE value above 1,000 nanotesla. AE drop below or 200 nanotesla, no longer than 2 hours at a time. Typically seen with coronal holes. So yeah, in short, you can have aurora for days, but it's mostly diffuse. However, you get sporadic brightening and substorms, which is what we saw in the past couple days. There were some, I mean, for those that could see it, we all know that us in the in the Great Lakes region saw nothing but clouds, and that's a different story. But from looking at different webcams and the reports coming in, there was sporadic brightening. There were some decent substorms out of it too, and which you can get that because it's in a continuous state, and it'll, tip here and there. Also note they're recognized retrospectively because you have to have that criteria listed above. It's got to go on for 2 days, so you won't be able to pick this up, as it's going. You have to look at it in the past. So, what's the difference between a CIR high-speed stream versus the CME? This one's kind of interesting and kind of important because you have different things that happen. And there's pros and cons to it. Like, I personally kind of like coronal holes and high-speed streams because you get longer duration events out of them. Everybody likes to hype up the, CMEs and stuff, solar maximum. But yeah, and cool. This is where you get the G4, G5 events, and the aurora gets pushed down to lower latitudes. But they tend to be a lot shorter duration. And then you have your risk for GICs, whereas you don't get that with the CIRs and high-speed streams. But if you're a satellite operator, you hate this stuff because it goes on and on and on and on and on. So you're always trying to do corrective active action for your satellites, and then it's, you can get these weird effects with the satellites as well. So because of the electron, relativistic electrons that come along with this stuff. So that's
For
kind
those
of
who get the SWIPSy alerts, you'll see the
yeah.
2 MeV electron flux is always above X PFU. I think it's 1,000 PFU, but yeah, those last for days during a coronal hole
Yeah, so
countdown.
for satellite operators, this is the part of the cycle they absolutely despise because it's a pain in the butt. CMEs you can kind of live through. They come in hot, and then they leave. So, and these pictures kind of explain it. You can kind of see there's you got your magnetic cloud here, and then you got the shock and the sheath, and then it's just coming through. But with the solar wind here, you get your shocks. You get the compression with the fast hitting the slow wind, and just kind of it'll hang out there for a while because then you get the high speed wind behind it. So anyway, I think that was our little last slide on that one. But that's what a HILDCAA event is. And we saw one, so it was cool to I'm gonna stop sharing here. It was cool to see because what's neat about doing these streams with it, starting in solar maximum and coming out of it is we can actually see these events happen. Like you read about them, you're like, it'd be cool to actually see one in the data, and now we're getting it. Because I remember Tanya saying, I really want to see a sawtooth event, and then we had a couple of them.
And then it's
So
like, I want more aurora. Make this
yeah,
go
so
away.
it's neat to read about it and then actually see it happen. So this is what happened the last couple of days. We actually got to see this. And now you all know what to look out for when you look at solar wind data with these coronal holes as we see more and more of them. So that's kind of what we had for the day. It was pretty simple and straightforward. I mean, we could go into more of what this event is, but it gets kind of complicated. And that's the important stuff anyway.
Yeah,
So,
the surface level, I think, is all I'd be able to describe right now.
yeah.
It's not an easy or intuitive area, especially with all the mess we had last night.
Yeah, we had a mess. Let's see if there's any questions in the thing. I don't think it was what she said. Like, I do kind of agree with that. It's like I think that's the longest acronym I've seen so far with any of these space weather related phenomenon events. Is that one, HILDCAA, HILDCAA.
It's not even an easy one to say.
But yeah,
I'm
and
sure we
then
can find a way to rephrase that, but
so yeah, and like Tanya said, Coronal holes are Aurora Chasers workhorse for some decent activity. They really are. It's like for us coming in the solar minimum, I like them because they're out of anything that we have, they're the most predictable because they're recurrent features. They
you can plan
happen
for them.
and then they come
Yep.
back around again. And if they drove good activity the first time, odds are they're going to do it again until they eventually move away. But I want to say like what was that one year? I think 2019 we had one recurrent coronal hole basically the
3 or 4
entire year.
rotations.
So you could plan your trip around the 27th. I think it was around the 27th of every month to go somewhere. So I personally like them. I mean, they don't drive the craziest aurora activity, but you can get decent G2s out of them. And then if you have a transient feature embedded in them, which you a lot of times do, that could push it into G3 territory. So for anybody in the northern tiered middle latitude regions, that's good. That's good visual aurora. I mean, if you live in Utah or something, maybe not, but you start getting to
Yeah, those
too low.
horizon reds. Well, you're not even getting many reds except for the CIRs anyway, so
Yeah, I think that was the other thing too. Is somebody brought up, this is a question that was on Facebook and we didn't have it in the slide. Is the ring current involvement? So CMEs typically will drive more of that because they're more intense or they're dense. So you get more of the like SARs and more of the subauroral ring current involvement with that. The CIR driven stuff not so much because it's more it's not as intense. So I figured I'd mention that. So that was in, we didn't have it in the slide, but I'll throw it in there. So anyway, long story short, that's what we have here. Let's see if we have any questions. I'm gonna look in the thing. Okay. I don't think so. So maybe we answered everybody's
pretty
questions.
easy
I like
night.
that. So anyway, we'll keep it short and sweet today. So that's what we have, and I'm hoping we can get this cool thing it's this interesting thing that we found out to you guys. But it's going to take a while to research it, but it's pretty cool. I mean, we didn't really see anything from it because of the clouds, but it's very neat. It's a very unique thing. So anyway, do you have anything to add?
I am good.
Okay.
That got all the words out that I was going to say as well.
I know. Sometimes I chit chat too much and talk too fast, but hopefully people.
I don't mind. Saves me the effort.
I'll ask Tanya. Maybe she put in the chat. Hey, did we do okay? So yeah, Janelle, the coronal hole. I mean,
the better aimed one will be the end of the week.
better aimed one. Put it that way. At the end of the week, there's if Christian, if you want to pull that picture back up, because there's like 3 coronal holes.
I will have. Yeah, I can. Give me a while.
So
I was pulling up. So I wanted to add to it. I was pulling up 2017 because the big CME we had for the downswing of cycle 24. And I wanted to say there was a coronal hole near that, and there was in the southern hemisphere.
Oh yeah.
Which was so like I've seen a few of these events before, but with bigger shows.
Right. Yeah. So sometimes you get it, and then it'll.
And then you get a semi-quiet sun. But just how weird that looks. Anyway, I'm getting distracted.
Yeah. So
let's go back to today.
Yeah, bring up the picture because we'll show Janelle the what we're looking at because there is like three little ones.
Yeah. Let's just go back to studio.
Yeah. But I know the Met Office has the main, not really a watch yet because I don't want to put a watch out, but for like probably the more.
So we probably won't get much up here.
Yeah, probably not from that one.
But this one here.
Yeah, because it's more central, and then we could probably get.
And then we'll definitely get something here. Yeah.
So yes, end of the week.
Is the moral of the story there?
Yeah.
And, yeah, that's true. Full moon this week.
Oh yeah, that's right. Yeah, the moon is full this week. So there's that. So that is a big party pooper. So you might get some if we get some decent storming from it, it'll be probably camera only. But if you want to go out. You can go do something with the moon. I'll be doing something with the moon for the first time in a long time, just because I'm going to be out for work. But, I don't do full moon stuff, but every once in a while, I guess you have to do something. So, anyway, yeah, full moon.
When it's all you've got.
But yeah, we don't have any Earth directed CMEs. Maybe we'll get lucky with this next thing that's coming through, but it's like it's always just a waiting game. A wait and see. And it happened last May, so never say never.
It's true.
I'll be the positive one on this whole thing.
And of course, Kirk is cheering the moon.
Yeah, because he's the one that gave me the idea. So I'm gonna try to do right by Kirk and make this plan work. So stay tuned. I'll send you some back of the camera shots. So anyway, thanks guys. Thanks for tuning in. We'll be back. We'll do one next week too. If nothing happens, we'll pick a topic and talk about it. So yeah, it is almost been a year since that May event. It's crazy. Time flies. So anyway,
We could do a Memories of May.
yeah, we could do Memories of May. Memories
Get some Aurora shots, do
of
some
the really good
explanations.
Aurora from 2024 that we haven't really seen anything
That we miss.
25 yet.
Hint, hint, son. Get on it.
Do something. All right. Thanks, guys, for tuning in as always. If you have any questions, hit us up. You know where to find us. And we'll see you next week.
Bye.
Bye.